Hey, welcome back to Math with Patrick. It's March 24th, and we have problem number 83 from this Daily Epsilon calendar that we're solving together. We need to find the number of ways to make 99 cents using some of the coins from 15 dimes, 15 nickels, and 15 pennies. Let's see. So our building blocks are dimes, which are 10 cents, nickels, which are 5 cents, and then pennies, which are 1 cent. And so I guess immediately to me, it's pretty clear that I need at least 4 pennies. Because if I'm counting by my tens and fives, the closest I can get to 99 is 95. And then the next nickel or the next dime will go over. So clearly, so first, let's see, let's just call, I could use D, N, and P as variables. So P has to be equal to 4, or I guess 9 is also okay, because I can create 90 cents out of dimes and nickels. And then looks like the next one would be 14. So P is equal to 4, 9, or 14. And then the next number that could work would be 19, but I don't have enough pennies for that. So let's take these as 3 separate cases where let's just talk about this 4 penny version first. I'll draw a little arrow, go over here. So now I need to make 95 cents out of nickels and dimes, and specifically under, or 15 or under of both of them. And when doing these counting problems, it's nice to do it kind of methodically. And I'm going to think about maybe maxing out the number of nickels I can use and seeing what happens when I decrease that down to, well, I don't think it'll be 0 because I can't do only dimes for 95 cents. So nickels could be anywhere between 1, because I need that 1 nickel at the very, very end. So 1, 2, all the way up until, well, whatever 95 divided by 5 is. You could do 5 times 20 to get to 100. So 5 times 19 gets you to 95. And you know what? It might actually be nice for me just to think about the nickels first. Why not? So make 90 cents because 9 of those cents are now pennies. Now I could have no nickels here because I could make 90 cents out of just dimes. So N could be 0 this time, or 1, or 2, all the way up until 18 now, because 18 times 5 gives me 90. And then for my third option, with the 14 pennies, I need to make 85 cents. And it looks like here I'm also running into that issue where I definitely need at least 1 nickel. So 1, 2, all the way up until 17. Got it. So, well, I guess I should just attach some dimes to each of these scenarios. And I guess it's kind of forced, right? Once I have 1 nickel, I must have 9 dimes. So D would be equal to 9. Oh, I just realized something. If I have 2 nickels, I have 85 cents now, and I can't make that out of dimes. So 2 is not a solution. The 3 would give me D equals 8. So actually, let me put that in the list. I just realized that. So with 3 nickels, I would have to make 80 cents. So D equals 8 is a possibility. And then finally, with this 19 nickel option, then I will have no dimes, D equals 0. So it looks like it might be easier to actually count my dimes here. I have 0 to 9, essentially. And so here it looks like I have 10 options, because I could have 0 dimes, 1, 2, 3, all the way to 9. That's 10 digits, 0 to 9. So I have 10 options over here. And I'm just double checking. I'm like worried to double count stuff. But at least for now, I don't think I'm double counting anything in here. I have 4 pennies, and then I have some odd amount of nickels and some amount of dimes, 0 through 9. For this 90-cent option, I am going to have that same issue when I have odd numbers of nickels, because if I include one nickel and only one, then I can't make 85 cents out of dimes. So similar issue where I can only pick the even numbers now from this list. So if I get n equals 0, so I have no nickels, that means dimes is once again 9. This one isn't a valid solution. With nickels equals 2, dimes would have to be 8. And then finally, with 18 nickels, I have no more dimes. Okay, 0. And counting up all the options, it's easier for me to count the number of dimes I have here, 0 through 9. Again, that is 10 digits. I have 10 options. So what's weird to me now is that I should expect 4 from this category on the right, but the pattern, like it won't I get 10? But since the date's 24, I guess I have to get 4 from this third column. Okay, so with 14 pennies, it's a new, unique scenario. And with 85 cents, I have to pick only the odd amount of nickels. Again, if I have an even amount of nickels, it doesn't work here. So let me just put another number here, 1, 2, 3, dot, 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 all the way up to 17. And then if I have 1 nickel, I have 8 dimes. If I have 3 nickels, I have 7 dimes. And then if I have 17 nickels, I have no dimes. So this looks like 9 options to me. So somewhere in here, I guess I must have double counted 5 of them. So give me a sec to figure out where those double countings are. Okay, I didn't double count anything. Maybe you realized this before me, but I just realized it now, that I only have 15 nickels to choose from. And if you notice here in my lists, 19, 18, and 17 are too big. So 15 is the largest number I could get. And in this list, 14 is going to be the largest number because 15, 15's odd and then 16 is too big. So actually 14 is going to be the largest amount of nickels there, and then 15 and 15 over here. Okay, so that's why I counted too many options. When I have 15 nickels over here, well, that was a 17, right? And I erased it, now it's a 15. So now I have 2 fewer nickels, so I need 1 more dime. Or in other words, 15 times 5 is 75. And to get up to that 85 cents, I need D to be equal to 1. So instead of 9 options, I just decrease the amount of options I have, and now it's 8. And now I'm kind of seeing it's probably going to be 8, 8, 8, right? Let's see. So for here, if I have 14 nickels, that is going to be 70 cents. And so I must have 2 more dimes to get up to 90. And it's not 7 options because maybe you see you take the difference, it's 7. But if you take the difference between the numbers, but you want to include both ends, you have to add 1. Kind of like here, it's a little bit easier to see that there's 8 options here. But if you just do 8 minus 1, you're going to get 7, even though there's 8 options to choose from. So between 2 to 9 inclusive, I have 8 options. And then with 15 being my maximum number over here, that's going to be 75 cents. And to get up to 95, I need at least 2 dimes in my pile. So again, 8 options here. So there we go. 8 options, 8 options, 8 options. Altogether, I have 24 different ways that I can make 99 cents. So before you go, I actually want to show you how you could do this graphically instead. So let's hop on over to Desmos. And this might be the first time that I'm using a 3D Desmos in my Daily Epsilon video series. And so it just has the standard XY plane. So if I graph like y equals x squared, there's that parabola. And you can even see that it's staying in 2 dimensions. But I do have this third z axis. So if I click extend to 3D, I'm not writing any rules for what z could be. So when I click this button, z could be any number, and so it's going to extrude or extend the parabola into this curved sheet. And so now I have a three-dimensional, or I guess, it's still a two-dimensional object, but curved into 3D space. And let's see, how am I going to use 3 dimensions to help us with this problem? Well, we have 3 different types of coins. We had dimes, nickels, and pennies. And I wasn't sure how many dimes, nickels, or pennies to use, so those are my 3 variables. Instead of d, n, and p, I'm going to use x, y, and z. So Desmos understands me a bit better. And then, so this right here is an expression for the amount of money I could create out of dimes, nickels, and pennies. So if you put like 1, 1, and 1 here, you're going to get 16 cents. I'm curious when this sum is equal to 99. It's not showing up because I need to zoom out. And we get a plane. So whenever you write an equation that looks like this ax plus by plus cz equals d, where a, b, c, d are all these real numbers, you're going to get a sheet or a plane. And this doesn't really help my search because this looks like infinite solutions to me. I have an infinite collection of points all hanging out on this plane, and all of those could be potential solutions for this equation. However, with coins, I can only have whole numbers. And also with the rules of this problem, I could only have 0 through 15 of them. Like, it doesn't make sense to have negative pennies. So let me change all of my axes to 0 to 15. And so all of my whole number solutions are going to be hiding somewhere in this plane. And then to convert between like any real number and whole numbers, why not? Well, we could either do the floor function. The floor function essentially just takes you down to the nearest whole number. So if we happened to do a negative number, the floor function still takes you down to the nearest integer here. But I think I might prefer the round function, where instead of taking you down to the next integer, it'll just round it to the nearest integer. If I pick like 2.5, sure, it'll round it up. 2.4 rounds down. And watch what happens when I start rounding the variables x, y, and z. So rounding just the x, I'm now kind of like limiting where that plane can be. Rounding the y gets me this picture, and I get these little, like, I don't know, small little boxes where I have potential solutions for my problem. And actually, if we count these up right now, I think there's going to be 24 of them. Yeah, you can see there's 4 and 4, so there's 8 on top. 1, 2, 3, 4, 1, 2, 3, 4, and 4 and 4. So it's kind of like how I found 8, 8, and 8. You can also see, knowing that Z stands for pennies, that we have 4 pennies in this bottom row, 9 pennies in this middle row, and then 14 pennies in this top row. And kind of funnily, if you included negative pennies, look, there they are. If you want to include a negative penny, now we have 8 more solutions hiding down there. But let's not. And just for kicks, what happens if we round the z value? Let's see. Looks like our solutions are now represented by spiky cubes. You can still count 8 on top, 8 in the middle, 8 on bottom. And so here is a visual representation of the 24 solutions that we found on the whiteboard. So here's where I'll leave it. Thanks for watching this video and finding the answer with me today. And as a treat, I'm waking him up from a nap, but here you go. There's Mr. Quilly. Okay, we'll see you tomorrow. All right, bye.